Right, so for question 3 here, we have 2 spinners shown in the diagram, and we spin both of them. So look at the colors. We've got red, blue, green on the first spinner and red, blue, yellow on the second one. So let's label that as spinner 1 and spinner 2. And we'll make a table first because that's what we're required to do here. So spinner 1, let's do that across the top. And we have red, blue, green, like that. And spinner 2 is red, blue, yellow. Okay, so let's make a table and we'll put all the outcomes into the table. So the first outcome will be red, red. And then we get blue, red. Then green, red. Then we have red, blue. Blue, blue. Green, blue. Red, yellow. Blue, yellow, and green, yellow. So I was writing the first spinner and then the second spinner. So what is the probability that both spinners show the same color? Think about that for a minute. So what's the chance they show the same color? So you go through and just highlight which ones are the same. So blue, blue, red, red. So these are the only 2 that have the same color. So we're going to have 2 outcomes out of a total of 9. So 2 out of 9 will be your answer for that one. You can leave as a fraction, that's fine. Part C, what is the probability of obtaining a yellow and a red? It doesn't say which order, so we need yellow and red. So which ones are yellow and red? Red, yellow. Any more? Yellow, red, yellow, red, yellow, red. No, no more. So 1. So this is going to be 1 out of 9 for that probability. What is the probability of a red and a blue? So how many red blues do we have? So 1 here and 1 here, 2. So that chance will be 2 out of 9. The same as the probability of having 2 colors the same. Okay, so in question 4, we have a diagram that shows 2 spinners again, and we spin them at the same time. Use a table to determine the probability of obtaining a total score of each of these numbers. So let's make our table first. So we'll call this spinner 1 and spinner 2. So spinner 1, across the top, we have the numbers 1, 2, 3, 4. And spinner 2, we have 0. We can put them in order, -1, 0, 1, 2. So -1, 0, 1, 2. The order doesn't really matter, depending on what we're doing, I guess. So now we need to add these numbers. So we'll go through. So 1 plus -1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. And 1 plus 0, 1. 2 plus 0, 2. 3 plus 0, 3. 4 plus 0, 4. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 2 plus 1, 3. 2 plus 2, 4. 2 plus 3, 5. 4 plus 2, 6. So you can see here we've got 4 by 4 table, which will give us 16 outcomes in total. So let's look at our questions. First one, what's the probability of getting a 6? So we'll go to our table and see how many totals are 6. And there's only 1 here. So that's going to be 1 out of 16. right? How many totals are 0? At the other end of the table, there's only going to be one total. 1 out of 16. We can only get 0 once. And for C, a chance of 1. Well, for 1, there are 2 numbers. So your chance of getting a 1 is 2 out of 16, which is 1 out of 8. So it's a little bit more likely than the other numbers. And 3, what's the chance of getting a 3? So we have 1, 2, 3, 4. So there are 4 3s. So we know there are 4 chances out of 16, which simplifies to 1 out of 4. Okay, so for question 5, we have 2 unbiased coins are tossed, and the probability of obtaining at least 1 head and no heads. That's what we want to find. So we try to make our table first. So coin 1 can either be a head or a tail. Coin 2 can be either be a head or a tail. So we put them into the diagram like that. We have 4 outcomes that could happen. So head, head, tail, head, head, tail, or tail, tail. So these are your 4 outcomes here, 4 of them. So we want the probability of at least 1 head. So out of these outcomes, I need either 1 head or 2 heads. So at least 1 head means the probability of either head, tail, tail, head, or head, head. And we have 1 of each. So this is a quarter, quarter, quarter. So 3 quarters. So 3 out of these have at least 1 head. See, 1 head, 2 heads is fine. It's a minimum you need is 1 head. There's a head here, there's a head here. Okay, so the probability of no heads is the same as 2 tails, isn't it? Tail, tail. So that is 1 out of 4. In question 6, we have 2 fair dice and we roll them, and the scores on each side are multiplied together. So the key word here is that we multiply the numbers from each side to give a total score. What is the probability of getting the following questions? So I've already pre-made the table. So we have die 1 and die 2. And then we add, well, we multiply the scores from each dice. So for example, 4 times 3 is 12. So they're all the products of each dice side. Okay, so what's the probability of getting a score of 12? So we go through our table and we highlight each one that is 12. So this looks like we've got 1 here, 1 there, 3, and 1 there. So we have 4 numbers which are 12. So 4 out of 36 outcomes, which is 1 on 9 for that. So your outcomes again are 6 times 6. 36 outcomes. We should have written that already. So 36 possible outcomes for the experiment. Okay, so what's your chance of getting a 20? So where are the 20s? So let's go through the 20s. 1 here, 1 there. So there are only 2 20s. So that's going to be 2 out of 36, which is 1 out of 18. So highly unlikely to get a score of 20. Not impossible, but not much chance of that. So what's about greater than 25? So which numbers are more than 25? 1, 2, 3. There is only 3 numbers that are greater than 25, the ones that I've circled. So 30 and 36. So that would be 3 out of 36, which is 1 out of 12. Like that. 1 out of 12, better. Okay, so a score less than 30. So less than 30 then is actually everything else, isn't it? So when you think about it, this was 30 here in yellow, 30 or more. Less than 30, when you look at the table, is everything else. You see that? Less than 30 is all the other numbers in this table. So that's going to be 1 minus this number here. So we can do it this way, which would be 11 out of 12. If you like, you can add up all of these numbers and you'll get 33 out of 36, won't you? And when you convert that, you'll get 11 out of 12 anyway. So that's the other way that you could do that question, but it's quicker just to subtract these three numbers from 1 to give you 11 out of 12. So even numbers, what are the even numbers? How many are there? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there's 27 even numbers. Okay, out of 36, which is going to simplify to 3 out of 4. So you're much more likely to get an even number when you're throwing your dice here.